Hello everyone. So today I'll be solving a reverse engineering challenge from a CTF that was hosted by IIT Bhubaneshwar, and the name of the challenge is random binary. So let's start. So we were only given this challenge file. If we check the file type, we can see that it is an ELF executable, but it is stripped out. Okay. So if we check out the strings, we have some pretty much useful strings over here. It says error during encryption, enter the password to encrypt, and probably it means that we need to enter something. And here we have a hex value over here. So if we check it, considering it might be the flag, we can see that it is giving us random bytes. So we don't know whatever it is, but we need to dig deeper for it to find out. Okay. And it says here, "God job, my friend, you did it, arrow, encrypted output, and all and all." Okay. So we can try to run it with ltrace, but actually this is not gonna give us anything useful. Let's see. No, we are not getting anything useful. We can try to run it with strace. Let's enter hello. Yeah, we aren't getting anything useful. So what we can do now is we can just open this binary in Ghidra. Okay, so if you are opening this binary first time, then you need to first of all create a project and then import this binary. Okay. So as this binary was stripped, you can see in the function trees below, you can't see a main function. So we need to go through these functions and see which is the main function. As we know that when we are entering our input, it is asking us, it is telling us enter the password to encrypt. So we can look for this string and probably that will be the main function itself. So let's look into these functions. Okay, so yeah, this is the main function. So we can see that here it is taking input in local 78 variable, and then it is initializing a local 80 variable, and then it is passing our input into a function. And after that, here it is doing some operations. Probably it is checking our input with these, and if this condition satisfies, then it is saying, "Good job, my friend, you did it." Okay. So first of all, what we need to do is we need to analyze this function. But before that, we see that in this b variable 7, in this variable, it is checking with I var 1 is equals to 0, which means that b variable 7 should be equals to 1 for this condition, if condition to be true. And when it will be 1, if I variable 1 is equals to 1. So it means we need to check this function. So it should return a value of 0. Then only it is gonna enter into this if loop over here, and it is gonna loop through this and will check our input with this, compare with this byte string, and then it is gonna print okay, good job, my friend. So basically we need to figure out the flag itself here. First of all, if you check out this function, it's taking parameter 1 and parameter 2. So what is parameter 1? Parameter 1 is the input that we are passing, and parameter 2 is that null byte, I guess, that was local 80. Yeah, so it is addressed to a null byte. Now if you check over here, it is first of all calculating the length of our input, and then it is allocating some address based on an input length. And after that, here first of all it is checking that if our input is null or not, then it will not be like returning 0. Okay. So here we can see that it is using srand. So what it is doing is it is shading it with 0. So the main part of this challenge is understanding this srand, because it is using this random function over here, which will be generating these random values. So the first thing that might come into our mind is we don't know this random values, then how are we gonna calculate the input? And the range of these random values are very large. Okay, so it is difficult to calculate this whatever our input should be, considering these random values. So the catch here is it is using srand and it is inputting 0 here. So actually what it means is it is seeding it with 0. So when it is seeding it with 0, srand with 0, it actually means that this program will create the same set of random values every time it runs. Okay. Uh, like in whatever system I run the program, and how many times I run the program, it will every time it will generate the same sequence of values. Okay. So you can test it out by writing a basic C++ or C code. I'll show it to you. Let's see. Let's open Mousepad and okay. So let's write a simple C code. Sorry, I'm writing a C++ code, not C. Okay. So I'll be trading as rand with 0, and then I'll loop, let's say up to 5. Now we can print the random values, and let's see what it gives. So yeah, these are the values it is giving. So what it means is every time you run this program, it will be giving the same values over here. Whatever system you run this program, it will be giving the same values. So here also, we can see that first of all, it is initializing some variables, doing some operations, and the main part is over here. It is actually converting our input, doing some XOR operations, doing some multiplication operations, addition operations, and then converting, and then it's actually saving our input to this address, parameter 2 plus L variable 1, and it is updating this L variable 1 every time. And first of all, how much up to when will this loop run? So first of all, it is checking s variable 1 until and unless it is equals to s variable 6. And what was s variable 6? If we check over here, first of all, it is initialized with 0. Okay, and it is being incremented each time in the loop. And what was s variable 7? It is actually the length of our input. Okay, so this loop will run till the length of our input. So the main part is over here. It is saving value calculator from here into this is the address it is allocating over here. Okay, so yeah, and this is the format string. If you check it over here, you can see it is actually saving it as hex values. So we can just write a brute force script to get the actual string that we need here, because if you go to the main function, where it is, yeah, if you go to this main function, here pb variable 3 is actually the pointer to our input that is stored in that memory location after performing some operations in this function. Okay, and p variable 4 is a pointer to this byte string. Okay, so now it is comparing each byte by byte, and it is checking if it is equal or not. Okay, so we can write a simple brute force script to do this, because as we know the random variables, so we can easily do that. So first of all, what I'll do is I'll convert this into a byte string. Sorry, I mean I will convert this into values, okay, into an array, so that it will be easier to compare. So here I'll open up a Python terminal. Let's see. Now we'll convert it into bytes. We can see we have the byte string over here, and we need to get the byte values actually. So I'll do list bytes from hex. Yeah, so we got the array. So now as we got the array, it will be easy for us to compare each byte. And yeah, one more thing is that we need to write this code in C++ as well, because if we implement this in Python, it will be generating a different set of random values, and that is not going to work here. Okay. Now I'll be taking this array first of all. Here it is. I'll copy it from here. Let's calculate the size of the array. Okay. So we got the size of the array. Now the characters might be small letters, capital letters, and curly braces, as it would be a flag, so it will also include curly braces, as it is a standard flag type, and it can also include numbers. So I will create a character set for it. So we can get the character set. Sorry, am I doing something wrong? Code string. Okay, we got the character set, and its data type will be string. I'll also be including curly braces and this underscore. Okay. Now what we'll do is we will loop through this array, and for every value we will loop through this character set and check, and we will actually perform this operation over here that was in the function. Yeah, so we'll perform this operation over here, and we will check for every character value if it is equals to this value or not. Okay, and that will probably give us a flag. So first of all, let's implement srand0, feed it with 0, and we will loop through this array. Sorry. Now, for every character set, first of all, we will be generating that random variable. Let's call it ivar3 itself, that was in that function, so that it will be easier for us to relate. Now we'll be creating this random value. Now I'll copy paste this part from here. So this will be basically our character. So for that, I'll loop through the characters. Okay, and here there will be a character which is char set of j. I'll remove this part, and let's store it in a variable call it b. Okay, so now we will check if this value is equals to array of I. Then what it is gonna do, it will print out the character set, and we will break this loop so that it will move to the next value. I hope there is no error in it. Let's try to run this code. First of all, save it. G++ $cpp. Okay, so it should be small letter. Yeah, I think it should work. Nope. Let me see where I have gone wrong. Yeah, the if condition is correct. Okay. Let me look at this error. Sorry, I didn't do. I didn't specify the data type. Let's run it. What's the error? Oh, it should be curly braces over here. It's not Python, bro. Anything else that is wrong? Okay, let me check it. What is wrong over here? Okay, so actually I probably got it. Here, there should not be a multiplication sign over here. It is doing XOR operation, as you can see in this. Actually, it was a pointer, so I didn't remove that multiplication sign. Now it should work. Let me check. Yeah. So let's run it. Why does it give only A? Did I do something wrong again? Okay, everything looks fine. What's the problem with it? Okay, I see. Huh. Sorry, I did one more very basic mistake over here. It should be J++ over here. Just a lot of basic mistakes. Let's compile the code again and let's run. Okay, so we can see we got the flag. So it was basically a simple challenge. What we needed to do is actually we needed to understand that it was using s rand 0. So actually it is setting with it with 0, which means that it will be giving us the same sequence of random values every time. Okay, and we just needed to implement this part over here. And what we did was we brute forced it with that hex string that was given, and we got our flag. Okay, so I hope you understood this challenge, and we'll meet in the next video with a new challenge.